Hello, my wonderful students. I'm sorry I could not be with you today. I promise we're almost at the end of the Jewish holidays and having to be out for robotics for a little while. Let's talk about today's stuff. Today is all about congruence. Just a reminder, congruence means when things are of the same size and shape. So let's just start off a little bit of warm-up discussion. Remember, if your artistry is not great on this, that's perfectly okay, all right? I'm not judging you on your skill to do this. If I showed you my notes, you'd be looking at it going, oh, that's terrible. Okay, so over here we've got some corporate design logos. You should notice a lot of symmetry in these, both rotational and line. You'll notice so that you've got a lot of mimicked designs. So it says a designer creates two versions of a new logo for a company. Version 1 uses the original image shown at the right. That's that kind of lightning bolt shape, and a reflection of it. Version 2 uses reduced copies of the original image. It says make a sketch of each version. Okay, let's do that. Now, first of all, let me warn you, not going to be great artistry, okay? So let's do a reflection. So if I did a reflection, here's basically what the original figure looks like. Again, I'm not judging you on your artistry with this either. This is kind of rough to do. So that's my best version of the original. Okay, let me do a reflection. Again, please do not stress if yours is not perfect, because guess who else's isn't going to be perfect? Mine. Okay, now you look at that. It's okay. It's a reflection. Now it says that you're supposed to do like some transformations of, let's see here, use reduced copies of the original version. All right. So here's what I've got. Reduced copies means that it's smaller. That's the only restriction on it. Here's one that's done with rotations, okay? So here's my original. So there you go. And if I wanted to, I could do something with a rotation. Let's see what I could do with it. Let me turn it this way. If I do that, let's see here. How could I do this? This is so tough to do these just kind of freehand. All right. How about, because I've already got the little reflection there. I don't want to spend too much time on this. Okay, so this way, down, at an angle, over, up, over. There we go. Something like that. Maybe you do the same thing again. Over, down, at an angle, back up, up, over. Okay, so there you go. You did something that's rotational. I did about 120 degrees. No, it's not perfect. It's not supposed to be. It doesn't have to be. All right, now it says communicate precisely. The owner of the company says, I like your design. That's a laugh right there. But it's important that the transformed image be the same size and shape as the original. What will you do to comply with the owner's requirements? Let's see here. Only use exact copies of the lightning bolt. We'll just call it a, I'll write it out. In the design. So what would I do with that? I might still use a reflection. I might still use a rotation, but I make sure that they were exactly the same size as the original. I would do that, using some editing software so I'd end up with the same size. Okay, so the rest of today's stuff should be things where you look at it and go, yeah, duh, of course it is. So let's talk about today's stuff. Suppose there is a rigid motion that maps one figure onto another, okay? Why does that show that the two figures are congruent? So I want to remind you, a rigid motion does not change the size or the shape. So, for example, over here in the picture, they did A reflection across line L, so that would be the second. So this is the pre-image. This is the image of the reflection. And then it looks like they translated 2 to the right and down 5. So down over here is the final image. So here's where you started, here's where you finished. And it says, how do you know that it's a rigid transformation? Well, here's how I know. All the angles are still 90 degrees, and the sides, and I'm going to put in parentheses here, corresponding, are congruent. So let's take a look at that in the picture, and then in the next line down, it's going to have us actually find those. So as you can see, this side is 3 long, and here's the corresponding side, HG, and it's 3 long. All right, now it says use math. Okay, it's on a grid, so we can do that. So first thing I'm going to do is I'm going to look at this figure and figure out how long all the sides are. So AB is, of course, 3, and BC is, of course, 1, and CD is, of course, 1, and DE is, of course, 2. By the way, if I've lost you, 3, 1, 1, 2. Then I go to EF, that's equal to 2. And then finally, FA, that's equal to 3. All right, so that's all the original. Now I'm going to do the exact same stuff down here. So starting in basically the same place, I've got GH. Then I've got HI. I've got IJ. I've got JK. Then I've got KL. And LG equal to 3. So all those sides are the same. And then you may want to add on yourself a little note. All angles are 90 degrees. So that's how we know for sure. Now here's your new little bit of vocabulary stuff. Let's kind of fill in the blanks. Figures that have the same size and shape are said to be congruent. And I'm just going to use the congruent symbol, but you could also put the word in here. If two figures are congruent, if there is a rigid motion that maps one figure onto the other. Just a reminder, your rigid motions are basically anything but a dilation because we haven't done dilations. So you got translations, you got reflections, you've got glide reflections, you have all of those things that you can still do. All right, going a little lower, a rigid motion is sometimes called a congruence transformation. Because it maps a figure to a congruent figure. Let's look down below. So these are a reflection across line M. That's what you see in that notation. Triangle A is congruent to triangle B because all of our measurements are the same on the corresponding sides and angles. And what I mean by that is C goes with C and F goes with F, cross that way because they're marked that way, as well as this. Please be careful. This does not mean this is an equilateral, equal angular triangle. I know it kind of looks like that, but they haven't marked it that way. So just be careful with that. All right, let's go to the other side and let's try this out. It says verify the triangles are congruent. All right, so to verify those triangles are congruent, we're going to find the rigid motion that will map one figure onto the other. Now, first of all, let me just tell you this is going to vary. So every single one of you may come up with a totally different way to do that, and it's totally okay. So here's one option that popped in my head. I will also give you another one. If you haven't thought of yours yet, take just a moment, pause the video, write down what you think it is. Okay, so when I was doing this originally, I thought about this. Translate 3, 0 after a reflection of 180 degrees around point Z. So that's the first one that popped in my head. Now why? I don't know, but that's what popped in my head, was to rotate around this point so that now my figure has an orientation that's, like this, but it needs to be shifted to the right. Just now as I was looking at this, I said, oh my God, you could also reflect across the line that's right here, which is the y equals 2. And then after that, you could also reflect. Now this would be really hard to do because it's a half. You could also reflect across the line x equals -1/2. And I'm sure that some of you have come up with even other ways to do that. So this one would be reflecting down this way and then reflecting across that way. That works too. So you got some options here. Please don't just limit yourself to what I write on the paper. Your ray may work beautifully. Okay, here's another one. Find a composition. Now I want to remind you a composition can be more than 2 items. I know I'm writing down 2, but that doesn't mean you have to do 2. All right, so this was the first one that popped into my mind. Translate 2 to the right and down 12, followed by a rotation of 180 degrees around the point 2, -8. I know, you're sitting there going, how was I supposed to figure that one out? Again, that's what popped into my mind. Here's another one that popped in my mind. This one's a little easier, a lot easier. Y equals -2, reflection. So here's y equals -2 is down here. So reflect across that, followed by a reflection across the line x equals 1. And again, you can come up with your own way to do this. There's not just one way to do this. Okay. If you need more time to play around with it, you take the time to play around with it. Again, not one way to do it. To be able to check with a person who's sitting near you and see what they came up with. All right, now it says determine which triangles are congruent by providing a rigid motion composition. Let's take a look at these figures. They all look like they're the same, but they're not. If you look at the piece that is right here and the piece that is right here, those lines have the same slope. This segment does not have the same slope. So the triangle that's over here, FEG, is not congruent to the other two. So if somebody asks you to show which ones are congruent, make sure you're looking at all the sides. So this has a slope of 1 up, 3 over. This one's 1 up, 3 over. So they're basically going to have the same length to them if I did a Pythagorean theorem. On the other hand, this one is 2 up and 3 over. Clearly not the same length if you look at it carefully. So here's what I can say. I can say that triangle ABC is congruent to triangle JKL. And the transformation that I came up with, remember you may have come up with your own, is I translated -3 down, and then I did a reflection across x equals -4. So that's what I came up with. So that is definitely how I did that one. Again, this one, these two are not congruent, and those two are not congruent because the lengths of this side not going to be the same as this one. So just kind of watch out for stuff like that. What if you pick this side instead with this one? Also not the same length. Not the same length. What if you pick this side? Again, not the same length. They drew them specifically to try and make them look similar. Okay, we are down to the end of our notes right here. So let's take a look at which pair of objects are congruent. All right, folks, you know you got to see this. Like, you got to see this. I know some of you are already like, A's congruent, B's not. Let's talk about why. So with this one, it's definitely a yes. And I could do a 90-degree rotation around the point that's in between them. And if I do a 90-degree rotation around this point, I will get the other shape. Okay, so I can do that rotation. Hang on, is it 90? Oh, it's 180. See, look at that. I got a mistake on my notes. Got to fix that. If I'd been there with you, I know one of you would have mentioned it to me. All right. And I also may want to combine that. Oh, hang on. I did do a 90 degree. Hang on, let me fix this. 90-degree rotation with a translation. So that's what I did. I didn't do a 180-degree rotation. I did 90 with a translation. That absolutely works. But again, you can kind of play with it, come up with your own combo, okay? Now this one, not the same shape. This looks like an F. This looks like an L with a little thingy bob on it. Yeah, there's no way to make this work, so I'm just going to say no. There is no composition of rigid motions that maps one figure onto the other. And that's kind of it. So that's our congruent stuff for today. Please make sure you go do the Savas assignment 4.1. Tomorrow you're going to do the Delta Math assignment. So today is Savas, tomorrow is Delta Math. Hopefully you will have no homework when you leave class today, and I hope you have an amazing day and that you get the best substitute ever.